Hello, in this video we will be using Python to solve applications of kinematic equations. Kinematic equations come up in physics, algebra-based physics. I've taken calculus-based physics a while ago and I can't remember if we had kinematics, if we were taught kinematics there or not, but I know for sure they come up in algebra-based physics. So that's what we're going to be looking at. I've already opened a Python Word or document, a new Python document, and idle, obviously, that's what we're going to be using today. So in the file I have made a comment. This is applications of kinematics, and then from SIMPy I've imported SIMPy, everything basically, and then I've commented equations that we will be using throughout this video or in this program. These are the kinematic equations. If you recall, x is 1/2 times the quantity of v naught plus v times t, or x is v naught t plus 1/2 at squared, v is equal to v naught plus at, v squared equals v naught squares plus 2ax. So those are the four equations that we'll be using, and I've also made a comment here that when we solve the above equations, if we're solving for these main variables like x or v, then all we have to do is copy and paste the equation into our the section of the code that we're trying to solve the problem, and we're going to sub values. That's it. We're going to sub values for the givens. Maybe we know t or a or something like that, so we're going to substitute. Or when we're solving for the other variables, say v naught, a, or t, say if we're looking at this equation here and we want to solve for t, then we need to do something else. We need to create a variable to store a solving for that for the unknown variable first, and then we can sub values afterwards. You will know what I'm talking about when we start creating our code. All right, so with that said, let's do number one. This is a kinematics problem. So it says, in getting ready to slam dunk the ball, a basketball player starts from rest and sprints to a speed of 6 meters per second in 1.5 seconds. Assuming that the player accelerates uniformly, determine the distance he runs. All right. So first things first, what I'm going to do, I'm going to make a comment, and we're going to list our knowns and unknowns here in this problem. So our unknowns, let's start with the knowns. It's v naught. We're just going to say v0, just like in the equations we have here. So v naught here is 0 because he's starting from rest. So that's 0. And then, so he sprints to a speed of 6 meters per second. So v final, or v, equals 6. Then make a semicolon, and then we have in 1.5 seconds, so that would be t. T equals 1.5. All right. So now that I've made those knowns and unknowns, let's actually put what we're looking for here. So we're looking for x. X is unknown here. So x, we're going to put a question mark next to it like that. That's what we're solving for. That way we will know which one of the equations above to choose. So that way we can solve for x in one go, basically. All right, so here, let's start building our code. We're going to symbolically define all of these variables and see which ones we were going to be using. This is going to be universal for the whole entire code or program in this video. So let's do that. X is symbol. Symbol is a command in SIMPy. So we've already imported SIMPy, so we can just symbolically define variables here. So x is symbol x, and then we have v naught equals symbol v naught. Symbol v naught, like that, like this, and then semicolon, v equals symbol here v, and then we have a and t. So a equals symbol a, like this, and then t equals symbol t. Like that. Okay, so that's the first step we're going to be doing, and then next step for us is to see which one of these equations we're going to be using above, and then we're going to borrow that equation. Either we're going to have to create a new variable, like the second step, or the first step, just copy and paste the equation and solve for it. So in this case, we're solving for x. That's the main variable, and we are given v naught, v, and t. So this equation, the second equation, has v naught, t, a. That's not what we're using. So the first equation has v naught, v, and t. So that's what I'm going to copy and paste. So copy and paste that, and then come down here. So we have that equation, and now we're going to create a variable called solutions, and this equals what we solve for. So in this case is x dot subs, and we're going to put in something like this. Let's see. So in the parentheses there, we're going to have substitutions. So v naught is 0, so that's v0, and then 0 here. And then we have, let's see. So make a comma here, and then v is 6, and then comma t equals, or colon 1.5. All right, so now we're going to close the parentheses like so. And now we're going to print the results to the user. So do print, and let's do a \n just to create a new line. So we're going to insert a blank line. X equals, this is %.4f, and this is going to be in meters. Go outside, % solutions, like that, and then close parentheses. All right, so that's all we have to do in this problem. So let's go ahead and run it. All right, so that's all we have to do in this problem. Let's go ahead and run it. So when I run it, I get that, let's see, x equals 4.5 meters. So that's what we were solving for. So we can make a conclusion that the distance he runs is 4.5 meters. That's what we're solving for. All right, so that's problem number 1. Let's do problem number 2 here. So let's go ahead and read it. So it says, a jogger accelerates from rest to a speed of 3.0 meters per second in 2 seconds. A car accelerates from 38 to 41 meters per second also in 2 seconds. So part A, it says find the acceleration in magnitude only of the jogger. So let's go ahead and, just like above, we're going to list our knowns and unknowns. So let's go ahead and copy and paste this and see what we're going to, how much of it we're going to use. Most likely we're not solving for the same variables. So we know we're going to need v naught because accelerates from rest to 3 meters per second. So v is going to be 3, and then this t is going to be 2. And we don't know, let's see, in 2 seconds a car accelerates. So for part A, find the acceleration of the jogger. So we're solving for A. So A equals something. All right, so I'm going to go ahead and copy and paste this line of code here and put it down here. All right, let's create a variable called solution1, and this equals solve. And then we have an equation. We're going to use one of the equations that we need based on that variable. And let's see. And outside of that equation, we have 0. The equation command gives the answer as a list, and we're taking the first answers from that list. So our answers will be returned not in a list. It will be an actual answer. All right, so let's see what equation we're going to be using. So we're given v naught, v, and t. We're looking for A. Let's go see which one that is. So it looks like this third equation is what we need. So we have v naught, a, and t. So let's go ahead and copy and paste this line here, and we're gonna put that in there like so, and then come outside, and the variable that is on the left side of this equation is v, because we have v equals v naught plus at, and then what we're solving for is, let's see, we're solving for a here, right? So do a comma a like that, comma v like this, and we shouldn't need that. Okay. All right, so that's that. So now solutions equals, we're gonna do the same thing. This is gonna be copy and paste that. So dot subs, and we're gonna copy and paste this line here. So v naught is 0, v is 3, like it's 3, and then t is 2. So let's go ahead and print, copy and paste that. So A here equals, this is meters per second squared, and percent solutions. Yeah, that should be fine. So let's go ahead and run it, see what that acceleration of the jogger is. So let's go ahead and comment all of this now, since we don't need those anymore. So I'm gonna run it and see what we get. So A is 1.5 meters per second squared. This is the acceleration of the jogger. So that's part A. So let's go ahead and do part B. So part B says determine the acceleration of the car. So here we're going to do the same thing. Let's go ahead and copy and paste this line there. So of the car, we're given that V naught is 0, or actually not 0. This is 38. So, and then V is 41. T is still 2 seconds, and we're solving for A. So we're going to use the same setup as before, and we're going to change some things, maybe some numbers in the variable, or in this part B. So let's see. So this should be all okay here, this line here, and then solutions. So V naught is 38, V is 41, and then T is 2. So let's go ahead and run that. Let's comment this one. So let's see what we get for part B. So A is, again, it's 1.5 meters per second squared. This is the speed of the, or acceleration of the car in that 2 seconds, for given that his rest velocity is 38 meters per second and final velocity is 41 meters per second. So that's the answer for part B. It's hard to believe that the car and the jogger have the same acceleration, but that is the case. So let's go ahead and comment that one. So let's see, part C, it says, does the car travel further than the jogger during the 2 second span? If so, how much further? All right, so here I'm gonna create some new variables. Oh, this is just for commenting purposes. So x1, let x1 be the displacement of the jogger. So we don't know what that displacement is. So then that's x1, do a semicolon. So x2, let that displacement be that of the car. So this is, we don't know what that is either. And then we're also looking for the difference of displacements. So those are the 3 things we need to find in this problem. So what I'm going to do is I'm going to copy and paste, let's see, this line of code here. So to solve for the displacement, let's solve for the displacement of the jogger first. Let's call this displacement of the jogger. So what we need to do is we need to borrow one of these equations that uses x as well as v naught, v, and t. Let's see what that is, which equation. So the first equation is what we need to borrow here. So copy and paste that, and we're gonna paste it there. All right, and then we're gonna substitute some values here. So we're gonna do x dot subs, just like the first problem. So solution, let's go ahead and copy that into part B. And let's uncomment it. So Alt and 4. All right, so V naught of the jogger is, we said it's 0, and V is 3, and then T is 2 seconds. All right, let's see what that displacement is. All right, so what I've done here actually is x is going to be the displacement of the jogger, and x1 is going to be the displacement of the car, and they're both in meters. And then in this last line of code for this problem, we take solution 2, that is the displacement of the car minus displacement of the jogger, and the difference is the displacement is the difference of those two, so that's the solution 2. And let's go ahead and run this, see what we get. So the displacement of the jogger is 3 meters, displacement of the car is 79 meters, and the difference of the two is 76 meters. So that's how we solve that problem.